All right, welcome everybody. I want to continue our work with density plots in this video with ggplot2 and talk about how we can add some additional aesthetics to a density plot that are going to be beyond just making some cosmetic changes, like I like this color better than that color, but ways that are going to help us see more features in the data and ways of helping us look at relationships between different variables in the data. So these are not cosmetic changes, but these are going to be like really important relationships between different variables in the data that we're going to be able to see. So in the previous video, we created a density plot for the bill length variable in the Penguins data frame. So if you're just tuning in to this video and you're like, I know how to create density plots in ggplot2, I just want to know how I can add a color aesthetic to it. There's a link to this notebook in the description of this video. If you want to catch up to what we're doing, you're going to want to go and make sure that you've installed and loaded all of the required packages. The quickest way to do that is to just go to runtime and then run before. That's going to run all of the code cells prior to this one. Then you can run this code cell. And as long as that runs okay, you're all caught up. If it doesn't run okay, then you might just want to go through this notebook and make sure that you've run all of the code cells prior to this one to get caught up. But this is looking at the distribution of bill lengths for these penguins. The issue is there are three different species of penguin included in this data frame. And these three species, they have different bill lengths. So they all don't have the same bill lengths. So their distribution of bill lengths for these three different species are going to be different. And that is why we're seeing these different peaks in this density plot. So one way that we can try and see the relationship between species and bill length is adding species as an aesthetic. So we've already taken into account the bill length. We can take into account species by mapping it to a different aesthetic, but we're not going to map it to the y-axis. We could do that, and maybe we'll do that in a later video with a different type of plot. But here, there are other aesthetics that we can choose. And if you're curious about these different types of aesthetics, there's a dictionary earlier in this Colab notebook that lists out a bunch of them. So we've seen what X and Y do. We've seen what color does, and we've seen what fill does. So the color was like the outline on a histogram. We've seen what fill does. We've played around with group a little bit. Yeah, and we'll see some of these others in a moment. So there are different aesthetics that we can choose. And so down here, we are adding a color to it. So if we add a color aesthetic to this density plot, that's the only change I'm making from this previous code cell. Otherwise, we're using the density geom. You can see we've got this created three different density plots, one for each species. So this mapped a different color for each species. So therefore, we got three different density plots in three different colors, one for each species. And that also created a legend on the right, because again, we did this mapping inside of the aesthetic. So this is a scaling. And whenever we do that scaling inside of an aesthetic, it by default creates the legend. And in this case, the legend is extremely helpful because we would not know which color corresponded to which species. So I think in this case, we really do want a legend here. So this is great. If you don't like using colors, so maybe you don't have a color printer, or maybe you're worried about people that are like visually impaired about seeing colors, they're color blind. Another way that you could encode that would be to use another aesthetic, such as the line type. So the line type will do things like make it solid, dashed, and dotted. And this created three different plots, solid, dashed, and dotted. And then it created a legend to say this one was solid, this one was dashed, and this one was dotted. Maybe that's not clear. Maybe you do want color for people that can see color. And for people that can't see color, you do want to give them some way of trying to differentiate that by using line type. So you very well could use color and line type both in the same plot like this. So now we've got color for species and line type for species, which is great. And you could choose a different variable for each of these aesthetics if you wanted to do that. So, for example, I could choose a different species for line type, and this is going to do something even more complicated. So this created like 9 different line charts. It created one for female chin strap. It created one for male chin strap, and so on. But I think this almost hits the point where like the plot might be too complicated. I don't know. There comes a point where like the plot gets overcomplicated and becomes unreadable. But the point I'm trying to make is that you can add additional layers on and start encoding more and more information about more and more variables. But just because you can do it doesn't mean it's a good thing that you want to do. So you need to kind of make the judgment call sometimes about how much information is too much information to include in your plot. Okay. So that was the color aesthetic. We could adjust the fill aesthetic by, instead of changing the color, by setting the fill inside of that, and just to see what that would look like. I think that, at least by my opinion, that's a little bit easier to read than changing the color of the line. This makes it really evident. However, these are laid on top of each other. So it makes it really hard to see, for example, the green density plot, which is hidden behind the blue density plot. And all the way in the background is the red density plot. So these are overlaid on top of each other. So here we're just kind of taking a little tour of all of these different aesthetics that are possible. There's color, there's line type, there's fill. And to go along with fill, what is another nice aesthetic is the alpha aesthetic. And so the alpha aesthetic sets the transparency. So if I set the alpha aesthetic to the same fixed value, then this makes it a little bit more transparent. So it's possible for me to see behind the different density plots as well. And let me just say, like, the closer we set this to 1, the more solid it becomes. The closer we set it to 0, the more transparent it becomes. So you can kind of just decide for yourself what you think is the right alpha value. Here, I've set the alpha value inside of the geom. I could set the alpha value inside of the aesthetic. I don't know, something like this. And that sets a different alpha value for each value of sex, or for each factor of the sex, for example. That is not at all what I want to do in this case, but just keep in mind that you could map a variable to the alpha aesthetic. I could do like Bill, I think Bill depth is one of these variables. And it didn't like that because that was a numeric variable. But there are all sorts of ways that you can customize this. But if I want to set the alpha value, the alpha transparency, to be the same for all of them, then I actually don't want it to be an aesthetic. I don't want to map a variable to that alpha value. I just want to set it to be the same for all, for everything. Then I would just set that inside of the geome. Okay, so that is a map on some of the various aesthetics that we can play around with. In this case, we're playing around with them in the context of a density plot. In the next video, we'll take a look at constructing box plots with ggplot2. Thanks, everyone.